Now in this video we are going to learn about level order traversal in binary search tree. Now we know that in case of level order traversal we are visiting all these nodes level by level. So in this binary search tree over here we have 4 levels. So in the first level we have only root node, in the second level we have 2 children, in the third level we have 4 children, and in the fourth level we have only 2 children over here. Now in case of level order traversal, first we are starting visiting the all elements from the first level, then the second level, then the third level, then the fourth level. And here in each level we are starting from left to right. So when we reach the second level we are visiting from the left child, then the right child. Now after visiting all nodes in level 2, when we are coming to level 3, one more time we are starting from the left node from here. If we traverse this binary tree over here using level order traversal, the order of visit in this case will be like this. First we are starting from the first level, then we are continuing to the second level, and in second level we are continuing from left to right, then we are continuing to the third level, in the third level we are continuing visiting elements from left to right, then at the end we are coming to the fourth level, and in the fourth level also we are visiting elements from left to right. So with this we have successfully visited all elements of this binary search tree using level order traversal. Now based on this logic, let's head over to Java and create our method over there. Now here inside binary search tree class we are going to create our level order traversal method. Now to create a level order traversal, as we said before, we are using queue data structure. That's why here I have imported queue and linked list data structure. So in this case we are going to use queue as an interface and linked list as a queue data structure. So here after post order traversal I'm going to declare our level order traversal like this. So it's going to be like this: void level order. So this traversal will not take any parameter. So in this case the first thing that we are going to do, as we did in case of binary tree, we are going to create a queue and we are going to enqueue the root node to this queue over here. So it's going to be like this queue, and this queue will be the type of binary node. Is going to be new linked list binary node. Now then we are going to add root node to this queue over here. So I'm just going to call add method of this queue. So it's going to be add root node. Then we are going to loop through this queue until we have visited all elements in this binary search tree over here. So it's going to be like this. While queue is not empty, in this case we are going to create a new node over here, binary node, which will be the present node, and this node will get the value that comes out of the queue over here. So here we are going to call remove method. So this remove method removes the first element from the queue and returns that element. So in this case we are setting it to this present node over here. Then we are going to print out to the console present node's value. So here I'm just going to concatenate it with the extra space because in this case our output will be more readable. Now after doing so, we are going to check that if the present node's left node is not null, in this case we are going to add left node to this queue over here, and then we are going to do the same operation for the right child. So if the right child is not null, we are going to add right child to this queue over here as well. So in this case it's going to be like this: if present node dot left is not equal to null, in this case it's going to be add present node dot left, and we are going to do the same operation for the right child. So we are going to add right child to this queue over here. Basically what we are doing over here is we are visiting all nodes level by level. The reason that we put first left child over here is that because in case of level order traversal we are visiting from left to right. So that's why first we are checking left child, then the right child. Now with this we have completed our method. So let's see how this is working in practice. So here we have created our binary search tree like this. So this is the tree that is shown in this picture over here. Now here if we run level order traversal for this binary search tree, it should print out the elements the way that it shows in this picture over here. Now if I run our code, now after running our code you will see that it's printing out to the console this order over here. Now this order same as with the order that is shown in this picture over here. So this means that our level order traversal method works the way that we want. Now let's see what's the time and space complexity for this method over here. Now it's obvious that the time complexity for this method will be ON, because in this case we are visiting all elements of the binary search tree. So that's why if the number of elements in the binary search tree is n, the time complexity will be ON. Now the space complexity is also ON because in this case we are creating a queue in the memory, we are enqueuing all elements to this queue over here. So that's why the space complexity will be ON when we are running this level order traversal. Now with this we have come to the end of this lecture. So in this lecture we have discussed level order traversal in binary search tree. Basically in binary search tree and in binary tree all traversals over here are same. So here in this section, I've just quickly recap them to show you that both of them are same. Now in the next lecture, we are going to see how can we search for a value in binary search tree. So see you in the next lecture.